for the Facebook picture.
Yeah. And so can somebody check if we are on YouTube live now? I can't wait. Yeah.
Yeah.
All right. Cool.
Showing this screen.
All right, guys. Thank you for coming. This is 42nd .NET Developer Meetup Tokyo, and we have free pizza, we have free drinks, and we have restaurant outside, Wi-Fi coding in front, and we have 3 speakers today. And I think 2 of them you already speak before, right? And we have a new speaker.
Look at me when you said that. You know how many times I've spoken.
Yeah, I don't know, so many times. All right, so please enjoy. We have the first 3 speakers, and while you are listening to the session, please consider to be next speaker. You are very welcome to be next speaker. All right, so go ahead. You can use this microphone, or you can also use that one. Either way. Let me. Which one is yours? Oops. Joe, could you check if YouTube is projecting?
I see the slides.
Right? Yeah. Okay, cool. I need it.
program and updated the function and the JetBrains underneath would have updated everything as well.
Here, what it breaks is that if you use something like JetBrains, JetBrains is going to do the work. But JetBrains, you need to do it one by one. And when you choose a function, you do this, and it works perfectly, like Roslyn does. So it's okay. What I'm saying that is a problem is that sometimes this reference, like the XAML one, this reference is built based on the compiled DLL. So if the DLL is not compiling, this link doesn't happen. So in this case, you may have the situation where the application is translated, but the XAML is not translated. So you have some situations where the Roslyn can catch up all the C# code, but not the not C# code, because the compiler cannot tell where those partial classes are, because we have the XAML partial class and the C# partial class. So we need this to be compiled for Roslyn, see them as just one class. So that's one of the situations where it may happen. And if you do this just string replacing, it's dangerous as well. So that's it. Any questions?
Do you consider, for example, every word that is not included in your dictionary?
Yeah. Yeah.
Permanent version of the same word?
Version of the same word depends on the context. So you should improve the dictionary in such a way that it can match that different situation.
We understand that, but for example, in that code, is still a example of some word that is not included in your dictionary. So it's not, it's an expression, it's not included. So if you translate the Japanese character from Genji, hiragana to the romanized version of the same word, it can make things more different or more clear for people.
I don't think so. What the application does is if an expression is not part of any dictionary, so the application includes that not translated in the new dictionary called not translated dictionary. So you can grab everything that was not translated. Having Japanese turn into Romaji, not that useful. It doesn't help at all, because if you know Japanese, you don't need Romaji. If you don't know Japanese, Romaji is not going to help you. So there's no point to have Romaji. We should translate to a language, English, Portuguese, whatever, or keep it in Japanese. That's the best option.
I have one comment.
Sure.
Yesterday, I read an article from the Japanese IT magazine, and they say to speed up their code, they use Japanese. So I think yeah, they will use Japanese.
Yeah, probably. Yeah, I don't see how fast can a Japanese guy type in Japanese. I'm not Japanese, sorry, but maybe you guys know if it's faster or not. For me, it's not. It doesn't look faster. So maybe I would say today.
Full width spaces met everything up.
Yeah.
And it's more like localized to English.
All right. Anyway.
Yeah. Okay. Yeah. So that's it. Thank you.
Great presentation. One sad news is that we use only microphone, so I
Oh my God.
All right, so now while Yuki is coming up, we take a 5 minutes break. So please come in back in 5 minutes, like 8:05. Sorry about that. I didn't check the audio. Yeah, my bad. Meaning you can come in back again next month to the exactly same session again for the recording. Yeah.
Oh, so garbage?
there a place for garbage?
All right, okay.
Oh, you can just leave it on the.
Just eat it.
Eat it. Eat the garbage. Yay.
So, right, what next? Are you ready?
Share.
All right. Yep. I think we're very smart. Oops. I guess it's okay. Hide password. Yeah. You can hide. Yep. All right. Your microphone. Yeah, it's on. So I already started projecting the screen.
Oh, yeah. Yeah, it's alright.
But you can start in 5 minutes.
Yep.
Any protein pizza?
Protein pizza, you can add your own protein. But I forgot to eat the protein pizza like cheese. It contains a high protein essence. Every nice
Okay. He's avoiding us for now.
Yeah. Yeah, sometimes it takes a lacuna.
It's what?
Lacuna, you know lacuna. It's a spa. Spa for a friend. Spa, yeah. 6%, like 6%. Yeah, but
It's very important.
okay, I like it. I like it. Maybe it should come here.
Yeah. Or he should buy me something.
Yeah.
Like dinner.
Yeah.
Even better. We have our own.
Okay, I like him. We should invite you to be very good.
Yeah.
Sorry, guys, just one thing. As the recording was not really recording the sound, my voice, so I think it's good. If you want, I can present it again, and then next time I'll do a commitment. I'm not going to do it, but I can do it. I can bring the presentation and add the source code to the GitHub, so you're gonna have that. So maybe you can play with it here. So I'll make a way that you can run that.
Right, or maybe a bit more detail about Roslyn, how Roslyn works. Yeah. All right, so thank you. And the next speaker will be Yuki, talking about entity framework.
Yeah.
Four or full?
Just full.
For full entity framework. And can somebody check if YouTube is up and running with voice? Because we don't want to keep showing the silent video. Is it?
Yes.
All right. All right.
Okay, cool. Can I use this?
Yeah, sure, boss. By the way.
Whose computer is it coming from? Yours or his? Whose machine is the microphone on? Are you sure? Don't mute yours. I muted mine. Okay. All right, let's start.
Okay.
Go ahead.
Yep, sure. Okay, hi guys. My name's Yuki, and yeah, I'm a programmer in Japan, and I've in my previous company I've used instead of Entity Framework, I've used something called Fluent and Hibernate, which I think is quite similar to Entity Framework in terms of code first. And I've been moved to a new sort of project, and they use database first. So it's sort of the first time for me to like see how this workflow sort of works and the sort of like struggles that I have with it. So this isn't going to take long, and it's just my like initial impressions on it. And yeah, so I'll just quickly just go through it and just talk about it, I guess. So what I'm sort of used to is sort of this, where you create your own sort of models and you create mappings as well, which then links to the database table. Yeah, I borrow a little bit. And so what for database first is uses ETMX file, which is basically an XML file that contains all the relationships and everything and all that. And when I first saw this, I thought, oh, okay, it's all right. And they sort of showed me how to use it and how to add new tables and update. But as I've gone along and I've used it, I found, because I'm a part of I'm one of 5 teams, and because we all manipulate the database and add tables, modify it, we're all updating this auto-generated XML file, and we're finding that we're having like way too many merge conflicts, and it's just a massive hassle to resolve these conflicts. And some people just give up and just re-update this page, and yeah, it's just a massive gripe. So for example, like adding a table, simply you just do this, and when it does this, it also creates the entity class as well, which is quite helpful. So I do see why people would use this, but for someone like me, whoa, okay, yeah, someone like me, like, so yeah, so it adds in the table, and you can even see the relationships and stuff like that, and you'll see that it'll even
sit there and spin.
Yeah.
Time to take a break.
Yeah. But like for code first, it does seem a lot better, because you can write everything in code and you can control the relationships quite easily, and you don't really have to go through this sort of auto-generated code. And the sort of thing that my team is sort of wanting to do is, like, every sprint, everyone who needs to do like database schema changes, they all do it at the very start, and you just chuck it all into one branch, and then you can update the EDMX file with all those changes on like a master database. And that seems to have solved it for now, but like you're still blocking everyone like on their tasks, whoever needs these sort of changes. So there is a bit of a trade-off, but yeah, for database first, I guess it's an interesting way of doing it. Wow, this thing's taking too long. Yeah. Okay, I don't know what my PC is doing. Another thing that I noticed is that when I started off this project, it's like halfway through its life cycle, and it used to use existing tables. So it had like one-to-one relationships with like unique foreign keys, and I noticed that for Entity Framework it doesn't recognize unique foreign keys. So you get these things where you have one-to-many where you shouldn't, and stuff like that. And yeah, that's also interesting to have. So so when you actually do generate the EDMX, you generate these entity classes, and yeah, you can see the sort of relationship. So this one, for example, is 1-to-1, so it's perfectly fine. And I'll show you quickly one of the sort of problems that we had. So there was, for example, there would be a table, like you would have a parent table, and then you would try and create a 1-to-1 where you have this unique foreign reference. And if we add that in, it'll take a while as always, but you'll see that it just gets like one-to-many, and I don't know what we're going to do with them other than like deleting them and recreating them.
This only works with SQL Server? Have an adapter to go to other databases?
I think it does have an adapter. Any database.
How about Couchbase?
Anything. Everything.
I won't generate it.
If it doesn't, as long as it does ODBC connector, it does.
So, for example, yeah, like there, it's got one-to-many, which it shouldn't. It should be like key. So those are the sorts of like headaches that we're starting to realize, and don't know why they went database first.
Right, so in this case, the notification table should have just one record.
Yeah, it should. Relationship, it should be like 1-to-1, and if I were to generate the entity classes, you would see that it will actually have a collection of notifications for one record.
It could be happening from the database design, right? Because the database always saying notification having one record.
Yeah.
And the record do not have any indication to the notification. Right?
Yeah.
I think the code is right.
That is right? Okay.
Because from database point of view, you can create a bunch of notification pointing the same record. So we have unique foreign key.
Yeah.
So that's it.
Yeah.
All right. So it's the framework ignoring the unique.
Yeah.
So maybe we should create the issued.
Oh, I don't even think Entity Framework supports.
I know, right? They're ignoring the unique.
Yeah.
Yeah, we should create the issue.
I actually think that Entity Framework is sort of stopped with database first, which is probably a good thing. And yeah, one way we are getting around that is just using a primary foreign key reference, and that's what I've been used in that country president sort of table. And that's, oh yeah, sure.
When you speak about database first, you mean like data first, so you have you plan your data,
yeah, so you,
classes first, and then you go into your code, how you execute this, and the other way around, or could you explain something?
Oh, okay. With database first, yes, you design your own tables first, and the entity framework will actually read your tables in your database and generate, yes, classes from those.
And are they listed as partial classes, so then you can then extend them using your own? Because those classes will be overwritten each time.
Yes.
So a way of getting around that to write your custom stuff would be to write separate partial classes.
Yes, I'm pretty sure that they're partial classes. Yeah.
I didn't notice they were, and probably another reason is because they have that little triangle next to them. I think they also have some other functionality of their own.
Yeah.
There's like a hidden file inside of that one.
I'm sorry. Oh, sorry. Which one?
Any of the ones with the arrow next to them.
Yeah. Oh, okay. Well, that's just a database context file, but oh, sorry. This one would be just these properties. Yeah. Yeah, there are partial classes though.
Yeah. So the basically you can add in any method, but you shouldn't add any property.
Okay.
Because if it's properties, that should be the part of the field.
Right, exactly. There's no need to, because you want that to be a mapping with the database.
And just real quickly,
What is this?
oh, just to see just the changes. So for this one particularly, it's quite simple. Like,
This toy skin?
oh no, this is Git extensions. But for something very simple, of course, it's just adding stuff in. But like when you get to more complex stuff, it's like removing tables and re-adding them at the very bottom, and that sort of creates the merge conflicts and stuff like that.
No.
So yeah, it is nuts.
Like Xcode storyboards.
Yeah. Yeah, that's all I wanted to say today.
All right, cool.
Cool. Thanks, guys.
Thank you.
You mentioned coverage.
Moving on from that, because the front-end Highmates are like a open source sort of thing. Yeah. I don't think it supports many databases and stuff like that.
Yeah, that's actually a good question about Docker. So the basically what we are doing from the data modeling point of view, if we already have data on the database, you may want to start from there, right? That's why we have the data fast, the data in. And if you already have the code, or if you have nothing, maybe you want to start from the code as a developer, right? And one thing we really need to be consider is that where we want to put in the logic. The speaker? Yeah. Yeah. No? I don't know. We need to think about where we want to put the business logic. So sometimes, like if you want to putting the logic inside the SQL Server, for example, like the start procedure, or even the trigger, which may be confusing to the developer because the developer simply simply try to do some insert by using the entity framework, but underneath database will do some transaction, right? But this is where we need to consider about the separation of concern. If that's totally database stuff, we should let the database to handle by themselves. But if that's the business logic for the application, we really have to think about our strategy, because I don't say everything should be coded inside the C# code. Anything can be coded inside the SQL Server, right? But we really need to think about the responsibility, which component take care, which business domain. And the reason why Dapper is great is because we can write in the optimized code, the query, by manually to make the optimized performance. Because the entity framework is applied for any database or DBC enabled, with meaning it may not guarantee the best performance. When you really need to write in the query, which you really want to run, you may think about a different strategy, including Dapper. Of course, you may lose in the compatibility. And another great part of the entity framework, which Yuki didn't mention this time, is unit testing. The entity framework is great for unit testing because it already has the data context, which you can use in like the mock service with the interface. So it's very, very easy. So if you have in the small to medium application, maybe entity framework is great. And I don't say entity framework is bad for the enterprise, but if you really need the performance optimized application, you may think about Dapper as an alternative solution. That's my own opinion, of course.
That's my experience as well.
So let me mute my PC. Mute. Yeah. Let me check if you are
Ooh. It's yellow again. Hold on a second. Let me disable this for another hour.
Yep, the microphone is on.
Cool, the microphone is on.
Yay.
Hello everyone, my name is Jim and I work at Couchbase. I'm a .NET developer for many platforms that .NET supports, including Xamarin Android, Xamarin iOS, UWP, .NET Core for Windows, Mac, and Linux as well. All over the place. So I'm in the very bowels and all over the place. And one of the things that I've been working with recently is this concept of actors. And so before I actually get into what actors are, you have to take a step back and think about what it's trying to solve. Like, what are the problems that we're facing today? What's the thing that brings pain to your brain? One of the most painful things you can think about. And that's something that didn't really exist as early as maybe 10 or 15 years ago. That's concurrent programming. Now we have machines with, first we had a dual core machine. Wow, we can do two things at once. And then we had quad core. And now we have like a bajillion core machine. And we have PlayStation 4s running in networks. And we want to just do more things at the same time. We don't just want to do one thing at once, because then why do we have all these cores then? And so we sort of took a natural evolution and we came up with something called threads, which are sort of like little encapsulated sort of encapsulated units of code execution that can be run in parallel. Well, sort of in parallel, you know, the CPU doesn't really run anything in parallel. It just stores a whole bunch of stuff in 6 different places and then switches between them and executes them one at a time. And so we evolved our understanding of how to do concurrent programming from the way that we had done single core programming. And we said, oh, look, if we try to access 2 things at the same time, we get into real trouble. So here's kind of like what we were thinking that was going to happen. This is the ideal case here, is that we have these 3 objects and we call method A and then call method B, it returns. We get a nice linear flow of things, but you know, like this picture where it just sort of goes in a nice straight line. But then once you start adding threads in, you get into sort of this situation where you've tried to, the other thing is in the middle of doing something, the CPU says, stop what you're doing now, pencils down, and let this guy do his thing. And you're in the middle of writing your name, so the other person gets half your name or whatever, with a bunch of garbage. Or in the best case, it'll crash. In the worst case, you got data corruption. And so, you know, what did we do? What do we do about that? We said, okay, we're gonna have like a policeman standing here saying, okay, now it's your turn. And while you're doing this stuff, I won't let anybody else in. Oh, is that thing showing? All right. So while you're doing your thing, as long as you're still doing this thing, I won't let anyone else in here, I promise. And they're just sitting there like hand waving, like dancing around like Michael Jackson in the middle, and trying to coordinate this access to data. And but as you can sort of see here, this ensures that at most 1 thread will enter the method at any given time, but this is a very costly strategy. Locks seriously limit concurrency. And the switching between these contexts is really heavy. And so the caller thread is now blocked, so it can't do anything else. It's just sitting there sort of freewheeling. It's like like if you've ever been to a tractor pull. I don't know if people outside the US know what a tractor pull is, but it's where these farmers who have a lot of time and apparently some disposable income, they will put these gigantic engines inside their tractors, and they will pull a really heavy piece of weight as far as they can before it just sort of spins in place. And sometimes the tractor's engine gets stuck and it just sits there and they can't get it to shut off and it's sitting there freewheeling. That's pretty much what this is. So it's just sitting there, not able to do anything until this thing is finished. It has to stop, wait for the other things, and you can't do anything. And so you've got a bunch of threads so what does the OS do? It makes more threads. And then now you've got a whole bunch of threads and you've just wasted a whole bunch of stuff. So this is actually this actor kind of idea is not a new idea, really. It came out in the early 70s and in a research paper, and it was popularized by the Erlang programming language. And it's a very cool way to think about concurrency. Here's kind of a graph showing of what it looks like. Each of these nodes here is an actor. Basically, this kind of borrows from functional programming, right? Each of the actors, they do mutate state, so it's not completely functional, but they maintain their own, like inside they're doing their thing, and they receive messages, they send messages, they respond to messages. They each are specialized in sort of one unit of work. They can do that unit of work, and someone else can tell them to do that unit of work. So say you have actor A and actor B. And actor A can say, do work B to actor B, and then there's no locking or anything. He just sends that message to tell actor B, do your thing, and then he keeps going on with what he's doing, not having to block anything. Then when actor B is done, if they need to tell actor A that they're done, they just tell actor A via message again, hey, I'm done. And this might be a little bit of a, you should really read this. This is the documentation of akka.net. You can just go to getakka.net, and their documentation is very comprehensive about explaining the whole pattern, and what their library is an implementation of this. So what I've done is I've taken the programming exercise that we did last week. I know there was like 3 people there last time, and I don't know if any of them are here this time, but I was hoping that some people at least would remember it, but let me refresh your memory. So I'll just play it real quick. Player 1's name is Jim and player 2's name is John. So this is the memory game, right? You have 10 cards face down. Sorry that it's gray there. So it's hard to see the gray. I made it a different color on purpose, but so now you have the 10 cards face down. You don't know what they are, so you go to pick one. Let's say I pick, let's first, I did improve it so that if I choose something stupid like that, it's gonna say invalid selection, please try again. Or, so I choose A1, and underneath A1 is the 3 of hearts. Let's try and like choose A1 again just for fun. If Jim did an oops. You can't choose a card that you've already chosen. So how about A2? No, that's not a match. Okay, let's try again. A3, A4. That's a match. Cool, then they're gone. It's because I got to keep them, and now my score, well, his score, the opponent's score went up. So let me just try to solve this to completion real quick. Is it 5? Oh, good job. E1 and A2. And player 2 wins. You might see all this junk in the background. That's just, I hadn't figured out how to get rid of that yet. And actually, I had not realized that the presentation was this week. I thought it was next week. So I was planning to expand this a little bit more than I did, but I'm going to explain to you how I was planning to expand it. But for now, I'll show you how it works. So I've got actors in here. So let's look at a simple one first. Let's look at the console actor. So for C#7, Akka's recommendation is that you derive from the untyped actor class, which has one method to override called onReceive. And then you basically make all these messages that it can receive. These are each individual classes, and you switch on them, and then handle them as they come in. So for example, if I have received a message called the write message, then I'll go down to here. And the write message on it it has a color to write the message in, and it has the message itself. And I can have a shortcut here for just a normal one. And this one just gives me a color based on the status code, which oops, that's the wrong combination. There we go. Normal, success, or failure. I've forgotten. Oh, here. Or for example, I named this after the example I found, clean read. There was also one called error read in that one, but I just kept the name because I didn't feel like rewriting it. Maybe I should have used the CINT tool to write English to English. Or I have like line break. It just writes a line, like an empty line, or clear screen, clears the screen. Or if it can even, you don't have to write your own class even. You can pass it just a string directly. If it receives a string, it's just going to write it there with the regular default color. And the default is to call this. This is a method that Akka provides to say that, I don't know what to do with this. And print a message saying, hey, you know, this message didn't go anywhere. It ended up in the dead letters box is what they call it. So let's see a little bit about how this flows. So I'm going to run it again. Oh, I should. I'll keep it on this one for the time being. So, oh, ignore this part. This is the part that I was trying to do to get ready. But let's start here. First, set the output encoding to UTF-8, which is the only sane encoding in the world. So please stop using everything else. And so here I'm creating an actor system. Actor system. Actor system is the top level entity in the actor world, in Akko's world anyway. The actor system contains all of the actors that you're going to use throughout your entire program. And so to start off, I create an actor of type console actor with a name that I predefined. And I also create a game actor. And props.create, I'm not really sure why they've done it this way. I'm sure there's some technical reason why they didn't just let me say new game actor, but they do a really good job of hiding everything behind an interface. So I'm sure that has something to do with it. But the way that I've set up the game actor is that the constructor here takes number of players and whether or not it's a server. The server is now unused because I didn't get that far. But so to start, well, let's go up to here. Can I do this in Mac? Maybe not. So now there's another concept in here that we show up with once we get inside the actor constructor, and that's the context. Come on, scroll over, please. This is you see this long, weird, scary-looking string here. This is actually the context of this particular actor. It comes in the form of a URL, and you should remember that it comes in the form of a URL because later that's going to play a part in the way that I was planning on expanding this thing. But so we take the context. The context has the ability to search for other actors that have been created already in the system and pulling them out. It also has the ability to you also have the ability to do other things like create a child actor. That's a fun thing to do because the child actor is monitored by the parent. So if you fail inside of a child, the first thing it's going to do is notify its parent. The parent can decide, oh, do I want to start this actor again, or do I want to pass this error up the chain of command to do something else with it? So here I create a child actor because I'm using the context. Here in the beginning, I was just creating them actor of right off the actor system. So that's the top level actors. If you go inside another actor and create via the context.actor selection or context.actor of creates a child actor. So each of these players, I'm going to create I'm going to create one. And there's another override method that I have here called pre-start. So I'm creating a player actor now. And this will tell the console actor to please read in player's name with this prompt. And the way I've set it up is that the clean read message will take as its first argument the message to create when it's returning. So you'll see it down here. I have some messages for any read results. So here's the name chosen. So let's put a breakpoint here just for the time being.
Is that like a callback?
It is kind of, it's like a callback, but it's not as strongly linked as a callback. It's very decoupled in that the callback is basically the same as calling a method and calling back are basically the same operation. They're just saying, hey, you do this. You just have to keep track of, you know, who's doing what and when.
So is this basically event-driven programming?
Sort of, yes. Event-driven. There's no really external events that cause this. They're kind of like a self-contained event-driven system where you poke it for the first event, and that sets off all the other ones that just keep going around until the context is, or until the actor system has decided to terminate. It's like sending the electron into the nuclear reactor to cause the chain reaction.
So in this, all of your actors are within the same process?
Yes.
But this could also be broken out into like a loosely coupled.
Yes, you're getting to the point that I'm going to make in a little bit.
Sorry.
But yes, you can see how this naturally follows, how this lends itself so well to distributed computing. So I'm going to go a little bit farther on this, and where's my, okay. A little bit farther on this, and then go into what I was going to do. So down here, so this is stuck here because, you know, inside the console actor, I'm waiting for the input. So I've typed Jim. Then when I hit enter, that triggers the console read message is now done. And it's sent back its message name chosen. So inside name chosen, it'll tell us the line that was received from the input. And so, okay, that's nice. Now I can tell my parent, because remember that this actor is a child of the game. I'm going to tell my parent that the player is ready now. And player ready doesn't really need any arguments, so I just use a singleton to avoid creating it over and over again. So the context parent is the game actor. Going back to here. On receive, player is ready. We're back to here again. So I increment the number of players that are ready. And this, the reason I did it this way is that when one player is ready, I prompt for the next, because when I didn't do it this way, they would come all in random order. If I said 5 players, it'd be like player 3, player 1, player 5, because, you know, there's no guarantee which order the messages are going to come in, just that they're going to come. This is remarkably similar to the way actual networking messages work, like TCP and stuff like that. They don't come just all in order over the pipe. They come in random order, and that's why you have this whole fancy handshake hack and everything to tell them what to do. So basically, I triggered the same thing again until this condition, I have all my players ready. And then I will clear the screen and begin the turn phase, which is where I start my logic. Current console tell it to write a line break, draw the deck to the screen, another line break, then throw it back to the player actor to say, please choose your card. They'll choose their card. When they choose their card, they'll throw it back to the game actor. Hey, I chose the card. Good. Choose another card. Okay. Throw it back to the game. Okay, you've chosen 2 cards. Do they match? They check that out. Oh, they match. Hey, you got a match. Good. I increment my score. You can see how it's going all back and forth and back and forth. And there's no locks anywhere. And remember before when I told you to look at the actor and see that it has a name, a path in the form of a URI. This is because Akka has another package called akka.remote, among other things, which lets you have remote communication, like basically RDP calls, I guess, over a variety of transports, really. I chose to try to do it over the TCP, which is why you see this sort of stuff scattered about my code. I was trying to make this work before I came here. I was thinking that I had another week to work on this, but you can see like a name like this. Instead of starting with Akka, it starts with akka.tcp. Ah, now I have an actor that I know I accessed via TCP. This is the name of it, and this is the address and port, and this is the path to retrieve the actor on the other side. Once you have a mechanism in place to do this, it's no different than if you have it inside the same process. I mean, it's the same thing. You send a message, you wait for a message to come back. It's the fundamentals of networking, just taken as a concurrency model. And the reason that I've been looking at this lately is because, first of all, our flagship product, Couchbase Server, makes extensive use of the actor model. They wrote a good majority of Couchbase Server in the Erlang programming language. And we liked it so much that we adopted it on the mobile product for the way that we do our replication algorithm, because we're sending messages back and forth to the server. We implemented our own actor class in C++, as we tend to do. But I think that if I could explore Akka a bit more, I could find a lot more to do with it. I know that it comes with a tool for like unit testing and debugging each of the actors, which is really nice, because you know that if that didn't exist, this would get really hairy really quick trying to figure out which actor had the problem. But yeah, if you're ever in a position where you think, I'm going to write something distributed, or maybe it could have the potential to become distributed someday, and consider using Akka or some other library. That Akka is actually written originally in Java. It was ported to .NET by the same authors, but it exists in several languages. And I'm sure there's other libraries out there as well that implement this model. It's getting fairly popular now. So that is the end of my presentation. Any questions about that?
All right, Christian.
Yeah.
So I understand we have the concurrent issue by locking and the synchronizing, and how this actor actually solve those conflicts to make it concurrency better.
Well, the actor itself, if you're familiar with the producer-consumer queue, that is a lockless way of dealing with communication that comes in from many places, but is only consumed by one entity. And basically every single one of the actors is its own producer-consumer queue. The producers are all the other actors that throw in messages to it, and it's the consumer of its messages, so it executes them one at a time in a way that's similar to, for example, like a task factory that only takes one task at a time, but takes them from many sources, or executes them on arbitrary threads. So you don't ever have to lock, because you're only doing one thing at a time. You're taking things from the queue, you're executing it, you're taking it from the queue, executing it. And so that helps with the concurrency, like the contention of the locks. And it also helps make it a lot more distributed friendly, I'll say.
So which meaning the locking is still happening?
Locking should not happen in a producer-consumer queue. It's like a Grand Central Dispatch on Apple, where there's a queue, and the queue just fills up, and the main loop inside of the actor is just taking this workout, executing it. When it's done, it's taking the next one, executing it. So there's
while executing something, if they are touching like the mutex, then the locking should be happening, right?
Yeah, well, then don't touch the mutex. There should be no mutexes either.
Right, and if we are writing the application which do not touching any mutex at all, outside the, even though we don't use the actor, it doesn't have much locking issue, right?
If you're using an app that doesn't have mutexes to begin with?
Yeah, so try to write in the code which do not have much locking, because the reason why we need to lock it to touching the same resource, right?
Mm-hmm. That's a big reason to lock, but locking is not the only way to deal with this issue. This is like a orthogonal way of dealing with this issue that replaces locking. Instead, it's using the concept of serial queues to make, if you only, I guess if you had two actors that were sharing the same object that was not an actor, that would be troublesome. But you should try to avoid that kind of design.
Or that's why people do things like idempotency and eventual consistency. I worked on a project within a healthcare company that embraced a lot of these ideas and enforcing things like if you run the same function over and over again, it gives you the same results.
Right.
That helps the underlying data become eventually consistent.
Right.
So the original problem was that you had two actors trying to work at the same time, and this frees it up so that the first actor does its job, and then the second actor doesn't even start until the first actor goes, okay, I'm done. Now you have something to do.
Right. So instead of two actors trying to go at it at the same time, which is the original problem all over again, you have them as children or sibling relationship, and then you tell one of them to go, and they'll tell the next one to go when they're done.
But it does not scale, right, from that point of view for that particular operation.
That particular operation, probably not so much.
Really, we need asking another actor to wait until I'm done. Right?
Well, it's not going to be waiting. It'll be doing other things while it's. If you don't send it the message, it's not like it's sitting there doing nothing necessarily. It could be other actors sending it messages as well. That's another thing. No idle threads in this.
Yeah, and it actually does scale because the original problem, you could have like something's trying to do work that it's wasting resources because it has no work to do, yet it's trying to do something. So you're freeing this from trying to do work, and so it actually scales much, and it's much friendlier in terms of threads, and you can then distribute this across different machines. So I think from a transactional processing standpoint, it's much more efficient. The actor model enables much more efficiency.
At some point, you'll bump up against legacy code, and that's always the case, isn't it? But that you have to take it all the way for it to be ultimately effective.
So rather than creating one guy doing one thing, creating the actor can handle multiple things to let them do whatever they can do at this moment.
You could do that, or you could have actors that did multiple things, but that would sort of. I would be afraid of that. That's like writing a God class. That's the same problem.
Yeah.
If you're doing, you want something to be like when you write your classes, you want it to do like one thing, and do one thing well, and have the other thing do one thing and one thing well. That makes it more easily testable. It makes it more reliable, and it makes it less prone to its own logic getting stuck at a hotspot.
Do we all understand? Am I the only one who do not understand this yet?
You have to study. I think there are a lot of concepts that you could probably benefit from by studying, like domain-driven design.
Mm-hmm.
If you study the basic ideas behind domain-driven design, this kind of stuff will begin making more sense.
Yeah, but domain design, it's more like design side, right? This is more like coding side.
Well, domain-driven design includes both principles and patterns.
Yeah.
So this came about because of people working with domain-driven design, I believe.
It's closer to how humans interact too. Like if you put 3 people in the room together, what are they going to do? They're going to say, okay, you do this and you do this and I'll do that. So it's more closely mimics the behavior of humans and networks actually too.
Right. In that case, actor can do at least 3 things, right?
Well, 3 actors will be doing 3 things at the same time.
Capability.
Yeah.
So maybe I just have a fundamental wrong understanding of this. The 3 humans in one room example. Right? I could tell them like, you do this, and you do that. Or for me, like when I think about distributed programming, I say, okay, you are 3 humans now. You can work at the same problem at the same time. I just split it up into chunks for you so that you finish one task 3 times as fast, and then you can move to another problem.
Yeah, it's kind of the same example, just in a different way. I mean, if you have like 3 small things or 1 big thing, you're dividing the work amongst yourselves and directing each other on how to do it.
And some problems are parallel, some problems are synchronous. So if you have a, so there's some things where you can split up, go do part A, do part B, do part C. But then there are other cases where it's like, well, I can't start part B until part A is done. And so this goes, it's like
dependencies and stuff.
Actor A goes, okay, B and C just hang out, be working on other stuff until I say I'm done with part A. And then when I'm done with part A, I reach out to actor B and go, yo, dude, time to get to work. Here's something for you to do. And actor C can like keep on playing his video game. And then when actor B is done with his stuff, he goes, yo, actor C, I need you to finish this up.
Okay, but during that, during those phases, those other actors would have something else to do.
Maybe they could have like, but there could be like 1,000 of these different processes coming in. And so one actor, you have different actors working on different parts of different processes.
So they could, but they don't.
Right, exactly. They don't have to. But because these are processes available to be accessed, all they have to do is receive a message, then they process the message.
All right, so please be honest, who still do not understand the benefit of the actor from the coding point of view. We all understand the briefly what's the idea, which may solve the concurrency issue, right? But who do not understand fully, deeply yet.
Who can understand it from like just 30 minutes of talking? It's
not
possible.
I know, but I just want to know who do not understand it.
I'm just trying to whet their appetite to get them interested in it.
And who will be coming next meetup? It will be 12th March. And keep raise your hand. And who do not understand the actor out of these guys? And who do you want to talk about actor next time? All right, so maybe you can do that. Sorry. Yeah, could you be the speaker next time to explain about the actor?
Sure.
The best way to study, learn something new is to teach others. This is a promising way to study, right? So I expect you to be a speaker to explain what actor is, who do not understand actor at this moment, who will be understanding actor next month, so that we can get the benefit from actor, right?
A lot of it, you can just read the ACA documentation and sort of parrot it back.
Right, because if you want to teach somebody, you have to read it very carefully to understand everything, right? And of course, I try to read through and I try to be a presenter of the actor, but we don't need 2 actor speakers anyway. So, all right, so please give him a big applause. So let me just put my slides up.
If you want to learn about actors, there's a guy I know that explains it really well. His name is Von Vernon. V-A-U-G.
He sounds very familiar to me by some reason. Is that very boring?
He's written like some really key domain-driven design books.
Okay, yeah.
So he's friends with Eric Evans, but he's definitely written some key books, and he explains these concepts pretty straightforward. Okay.
All right, so unfortunately it's time, and I hope you all enjoy it. And the one thing we need to do as a community is we need to take a picture all together coming in front. So before doing that, did everybody write it down, your name and the company name? If you do not yet, please talk to me later so that I can capture your name and the company name. And we need to take a picture. And the next meetup is not will be, but the next meetup is 12th March. I already booked the room. So I try not to confuse Jim. Because every time I announce next time will be, and actually the date will be changing all the time. The next time, 12th, I already booked this room. All right, so thank you everybody, and please come in front to take a picture. Let me stop the broadcasting. Goodbye, YouTube.